Day 283 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems and our determination goes unmatched, y'all. Today, we have question number 149, max points on a line. The difficulty level is hard, but don't even worry because we're going to keep the solution as simple and easy to understand as possible. So let's see what the question says. Question says, given an array of points where points I is equal to xi and yi represents a point on the xy plane, return the maximum number of points that lie on the same straight line. All right, y'all, so it sounds simple enough, but let's go ahead and look at these examples so we can know what it is exactly that they want us to do, right? So in example 1, we have the input points equals a 2D array of integers, or a 2D array, not a 2D array of integers, equals an array of points on a graph, which with the first point being 1, 1, second point being 2, 2, third point being 3, 3. The output is 3 because we want to return the maximum number of points that lie on the same straight line, right? And in this case, this straight line has a maximum number of points of 3 points, right? So the output is 3. Now, you might think, well, there are only 3 points that they gave us in the output or in the input, so of course the output would be 3. But no, that's not the case. Let's look at example 2 where the case may be different and they give us the points scattered all across the graph where we have to find a straight line within those scattered points. So in example 2 now, we have our input points equals an array of points. First point being 1 and 1, second point being 3 and 2, third point being 5 and 3, fourth point being 4 and 1, fifth point being 2 and 3, and the last point being 1 and 4. This time the output is 4 because out of all these points, there are only 4 of them that will give us a straight line, and that is point 1 and 4, which is right here, boom, which is also right here, shown right here. Then we have point 2 and 3, right? So 2 and 3, 2 and 3 right here, boom. Come over 2, up 3, boom. Then we have point 3 and 2, which is right here, boom. Then we have point 4 and 1, which is right here. So those are our points that give us our straight line, and there are only 4 of them, right? As you can see, there are 2 oddball points just off to the side somewhere that are not included in our straight line, which is this one, 1 and 1, and this one right here, 5 and 3. But as you can see, they're not included in our straight line. We could have get a straight line this way, but that straight line would only have 3 points. We want to return the maximum, right? Maximum number of points. So that's why we chose this straight line that has 4 points. And since there are 4 points, the output is 4. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution not that difficult either. And remember, y'all, when we're doing the solution, the output is the number of points. It is not the points themselves. We're not returning the points themselves. We're just returning the number of points. So let's get into the solutions. Now, first thing we need to do is we need to create a helper function which will help us calculate the slope and intercept of a line given 2 points. So in order to do that, we're just going to come right here, still inside the class, but outside the main function, so we can create our helper function, and we call it func, we call it line of 2 points. Just like that. Open up the parentheses. We'll say underscore ID x0, x0, colon, that will be an integer, and that will represent 1 index. Then we'll do another underscore ID x1, colon, and we'll set that as an integer as well. Then we'll say comma, come under that, or not under that, but underscore, come over, say underscore, then we'll say points, colon, that will be a 2D array of integers, and it is going to return a tuple. Open up the parentheses, it will be a double, comma, double. Then we'll come right here, boom. Open up the brackets. Now, we need to create a constant to represent our first point, so we could just say let P0, we call it P0, set that equal to points, open up the array brackets, and we'll pass in IDX 0. Then we need to do the second point. So we just come right here, come underneath this. We could say let P1, set that equal to points, open up the brackets, and we could call that ID, or we could pass in IDX1 for the second point. Then we need variables for the slope and y-intercept. So in order to do that, we can declare a variable called k, and we'll set that as a k. That'll be a double, and that will be the variable for the slope. Then we also need a variable for the y-intercept, so we could declare this, we could just call this a colon, and that'll be a double as well. Now, we need to handle the case where the horizontal line, meaning they have the same y value, so we could just come right here, we could say if P0 square bracket 1 equals P1 square bracket 1, then what we can do is we can open up the brackets, we can say k equals 0, and then we can say a equals a double, open up the parentheses, P0 square bracket 1, just like that. Now we can say we need to handle a case if it's a vertical line, meaning it's on the same x-axis. So we can come right here and we can say else if P0 square bracket 0 equals P1 square bracket 0, then we're going to open up the brackets, and now we need to assign a large value to represent an undefined slope. So we could just come right here and we could say k equals double, open up the parentheses, int dot max. Then we need to store the x value instead of the y-intercept. So in order to do that, we just come right here, we say a equals double, open up the parentheses, P0 square bracket 0. Boom. Then we just need a general case which will compute a slope and a y-intercept normally, right? So we could just come right here and we can say else, open up the bracket, we can say k equals, it's going to be a double, and we're going to open up the parentheses, we're going to say P0 square bracket 1 minus come outside the square bracket though, but still inside the parentheses, square bracket minus P1 square bracket 1. Come outside the parentheses. Now we're going to divide that by a double, and that double is going to be, open up the parentheses, we're going to say P0 square bracket 0 minus P1 square bracket 0. Boom. Then that's k. So now we need to do a. We're going to say a equals a double, open up the parentheses, P0 square bracket 1. Come outside of the parentheses, we're going to say minus k times a double, double, open up the parentheses, P0 square bracket 0, just like that. And then we need to return the computed slope and y-intercept. So we're just going to come right here and we're going to say return, open up the parentheses, k comma a, just like that. Now that is our helper function. We still have to get into the main function. So let's get started with the main function. Now, first thing we need to do, we need to check if there are 2 or fewer points, all points are on the same line. So we could just use a guard statement to handle that. We can say guard points dot count is greater than 2, else, open up the brackets, and we're just going to return points dot count, just like that. Boom. Then we're going to come underneath that. We're going to declare a variable called map, and that's going to be declared variable. We'll call that map. Then we'll say colon, and that's going to be a dictionary that stores sets of points indices for each unique value. So, or each unique line. Sorry. So in order to do that, we are going to say, come right here, we're going to open up the square brackets. We're going to say string colon set. It's going to be a set of integers. So set less than int greater than. Come outside, we're going to initialize it with a blank dictionary, just like that. Now we need a variable to track the maximum number of points on a single line. So we could just declare a variable. We could just call that max and set that equal to 0. Now we need to iterate through each pair of points to determine the unique lines. So in order to do that, we use a for loop. We say for I in 0 up to points dot count. I'm going to open up the brackets. I'm going to say if I plus 1 is greater than or equal to points dot count, open up the brackets, and we're going to break. So this is going to ensure we have at least 2 points to form a line. Then we're going to come, we're going to come underneath this, and we're going to say for j in I plus 1 up to points dot count, open up the brackets again. We need to get the line equation, or we need to get the slope and the intercept. So we are going to say let line equal line of 2 point, which is the helper function we just created. Then we're going to open up the parentheses. We're going to pass in I, comma, j, comma, points, just like that. Then we're going to come underneath this, and we're going to say let key equal. We're going to use some string interpolation. We're going to open up the quotation marks. We're going to say slash, open up the parentheses, line dot 0, close the parentheses. Then we're going to say minus slash, open up the parentheses again, line dot 1, close the parentheses. Boom, just like that. And that's going to create a unique key for the line based on the slope and intercept. Now we need to retrieve the existing set of point indices for the line or initialize a new set. So in order to do that, we're going to come underneath this. We're going to declare a variable called indexes with an S, and we'll set that equal to map square bracket key, and that is exclamation point nil. So if it does not equal nil, we're going to say question mark map square bracket key exclamation, or outside of the square bracket exclamation point colon set of integers. So set less than sign, int greater than sign, and then put 2 parentheses at the end. Now we need to add the first point of the pair, so we could come right here and we just say indexes with an S dot insert, open up the parentheses, I. So we're going to add the first point of the pair. Now we need to add the second point of the pair. So we're going to say indexes dot insert, this time open up the parentheses and pass in J. Then we need to store the updated set back in the dictionary. So in order to do that, we're going to say map square bracket key equals indexes. And then we need to update the maximum number of points found on a single line. So in order to do that, we just say max equals max greater than map square bracket key, come outside the square bracket, exclamation point dot count. Then we'll say question mark max colon map square bracket key, come outside the square bracket, exclamation point dot count. So what this is going to do is going to see if max is greater than. If that's true, then it's going to return max. If max is greater than the map.key.count, then it's going to return max. If this is false, this is going to return a Boolean. So if it's false, it's going to return the map key.count. If it's true, it's just going to return the max. Now we need to actually return the maximum number of points that lie on a single line. So we're going to come right here, and all we have to do is say return max, which we just created right here. Boom, or fix or update it right there, sorry. So boom, let's run this, see how it runs. Can we get it? Oh, we got an error. So it says error expected after if. So let's see, do we not, what's going on here? Let me see, my bad, y'all. My bad, y'all. So, oh, sorry, y'all. Equal white space. Equal white space. Get you every time. Let's see, y'all. Now let's see. Okay. Can I find P in scope? Oh, so this should be, I think this should be a 0. Let me see. I think, let me see. P0, I think. Let's try it. Let's see, let's run it. See if that works. No. Oh, hold on. So no, should be P0, and the parentheses should be after the square bracket. So now let's run it. See if that works. And it's accepted, y'all. That's what I'm talking about. So let's go ahead and submit it. See if it still works after we submit it. See, we all know how these LeetCode problems can be. Ooh, look at that. 62 millisecond speeds, 13.33% of users with Swift, y'all. Now, don't worry about the numbers too much right now. We just want to be able to solve the question that is presented to us. We'll get those numbers up as we continue down our LeetCode journey, and we've done a few of these problems and actually understand completely what it is that's happening. But until then, we just want a solution that we can understand while we're coding it and that we can learn from. And then we'll worry about the time complexity after we've learned what we needed to learn. So with that being said, y'all, make sure y'all get one more look at the code. This is the helper function right here. Get one more look at it. Is this the whole? Yep, that's the whole helper function. So boom, this is the main function right here. Get one more look at it. Read it, learn it, love it. There's still more. It's right here. That's the end of it right there. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. I will see y'all then.